Hi everybody, Ms. Z here, and today we're going to talk about density. So in your notes, you're going to copy down this information. You can either type it into your Google Doc or you can handwrite it in your notebook. We're going to be doing a lot of calculations, so it's probably going to be easier for you to write it in a notebook or print this out at home and copy things down that way. So the first one is on density, and we have some vocabulary to look at. Density is an intensive property that depends only on the type of substance, not the amount of the substance. So intensive is something that's dependent on what you have, not how much you have. So that means if I was looking at the density of water, I would find that my density of water is 1 gram per milliliter, no matter if I had 1 milliliter of it or if I had 100 milliliters of it. It's always going to be the same. Density is found by taking the mass of something divided by the volume. The units on density are grams per milliliter, or we can say grams per centimeter cubed. That's because a milliliter is equal to 1 centimeter cubed. So that is a cube of 1 by 1 by 1, 1, 1, 1. That, fill that up, would fill and hold 1 milliliter of water. We can also show our equation for density by saying D equals M over V, mass over volume. And we can see that from our units of grams per milliliter. Usually, the density of a substance increases when its temperature decreases. So as things get colder, the molecules move closer together. As they move closer together, they become more dense or more tightly packed within an area. This is true in everything except for water. We know that ice, which is at a lower temperature than liquid water, ice floats on water. And if it floats, that means that it's less dense. So because of that, life as we know it exists. That's a good thing. But it is against everything else. Everything else increases in density with a decrease in temperature, except for water. Water decreases density when the temperature decreases. So with density, we're going to go through some practice problems. So our first practice problem here is on a weather balloon. Our weather balloon is inflated to a volume of 2.2 times 10 to the third liters with 37.4 grams of helium. First thing we always want to do when we're doing a calculation is pull out our variables. So we see that we have liters here. Liters is volume. So we're going to say that our volume is 2.2 times 10 to the third liters. And we're given grams. We know that grams is mass. So my mass equals 37.4 grams. Now, in our formula for density, we can see that volume is either milliliters or centimeters cubed. So we could possibly have to change this into milliliters. Luckily, though, it asks for the density in grams per liter. So we can leave this as is. So we're looking for density. So we're asked to find what is the density in our units of grams per liter. So we can see if our units are grams per liter, we're going to need to take our mass and divide it by our volume. We always want to write our formula. Density is mass over volume. And then we're going to plug in our numbers that we have. So mass is 2.2 times 10 to the third and put in our units of liters. Divided by our volume. Whoops, I wrote that wrong. Just kidding. We'll write that here. My mass is 37.4 grams. And my volume is 2.2 times 10 to the third liters. Okay, units on both of them. I can see my units of grams per liter will come out, which is what I want. Now, plugging this in our calculator, I am going to, let's see if you can see this okay. There you go, that's a little easier. So we need to take 37.4, so we're going to type in 37.4, divided by, and this is in scientific notation. So to plug this in, we write 2.2, and we press the E button, 3, and that gives us 2.2 times 10 to the third. So I type in 2.2. My EE button is above my comma, so I'm going to do second comma. and then the number 3, and that gives me 2.2 times 10 to the third. It's important that we use this button. We're going to use it all through the course, but it's going to make sure that we don't inevitably add a factor of 10 to any of our numbers or miss a factor of 10. So I do that. I click enter, and I get a number of 0.017, and my units I carry over grams over liters. Okay, let's go ahead and do our next question. What is the volume in cubic centimeters? So that's what I'm looking for. What is? So volume, and my units are centimeters cubed, of a sample of cough syrup that has a mass of 50 grams. So my mass, 50.0 grams. And the density of the cough syrup is 0.950 grams per centimeter cubed. Okay. The formula that we have is density equals mass over volume. And we plug in the numbers. We're given density, so we know that 0.950 units are grams per centimeter cubed equals mass of 50.0 grams divided by my unknown variable of volume. To get volume by itself, right now it's at the bottom of a fraction. We're going to pretend that this is over 1 and cross multiply. So I'm going to have volume times 0.950 grams per centimeter cubed equals 50.0 grams. And I'm going to divide off by what I don't want, which is this, because I want volume to be by itself. So 0.950 grams per centimeter cubed. What I do to one side, I have to do to the other. So to find volume, I need to take 50 divided by 0.950, and I get 52.631. For as far as sig figs go, I have 3 here and 3 here, so I'm going to do 52.6. In my units, grams cancel out with grams. I'm left with 1 over centimeter cubed, so that leaves me centimeter cubed as my units. Now for my last question, I have a plastic ball with a volume of 19.7 centimeters cubed. So my volume, 19.7 centimeters cubed. It has a mass of 15.8 grams. So I record that. Would this ball sink or float in a container of gasoline? The density of gasoline is 0.66 to 0.69 grams per centimeter cubed. So I need to know what is the density of the ball to see if it's greater than or less than the density of my gasoline. Remember that density is equal to mass divided by volume. I plug in my variables. 15.8 grams goes with my mass, divided by my volume of 19.7 centimeter cubed. I plug this in my calculator. 15.8 divided by 19.7. I get 0.802. 3 sig figs here, 3 sig figs here, 3 here because this beginning 0 doesn't count. Units of grams divided by centimeters cubed. So if the density of my ball is 0.82 and the density of gasoline is 0.66 to 0.9, I can see that the density of the ball is greater than the gasoline. Therefore, the ball will sink.